I decided to talk this year a bit about bad code, and because I got into thinking about this topic last year in fall, when basically the time was to think about talks for this conference. And yeah, if you want to contact me about this topic later, you can do this per email or on Twitter, or there's also on Freenode, a chat channel. And before I start, a few words about me. C++ since '98. I've been at Vodafone for a few years, being a freelancer. Started the C++ user group in Düsseldorf in 2011, and 2 years ago Meeting C++ started, and basically the idea for Meeting C++ was also partly born here in Aspen. Meeting C++ has become a bit bigger than I actually planned it. It's now at 300 attendees this year, including 50 students, which is sponsored by a company. So for students, attendance is free. They just have to send their submission to the company. Yeah, and website, blog, etc. Platform for user groups. But actually, I'm here to talk about bad code. So my first question to you is that valid code? Does it compile?
Yes. Of course, it's a trick question.
Yes. That's actually lambda. It's called the Berded lambda, which of course it doesn't do anything. So then bad code.
Only if you have two of them.
Well, that's a point where we can argue if Goto is not bad code at all already. But you know, it shouldn't have happened. It's a bug. To me, it's probably not even bad code. It's just a bug. It's fixed. Wonderful. But you know, we first all laughed at Apple, and then a similar bug showed up in GNU-TLS, which is an open source implementation for Linux. And well, we probably thought it wouldn't come worse than this year. Then we had Heartbleed just a few weeks later. Again, just a small bug, nothing big, but you know, I think this was the most effective bug which we ever had, hopefully. So, talking about bad code, maybe it's your own code. Does anybody of you write bad code?
Oh yeah.
Some people in it. Okay. No, maybe it's the person next to you. Or very, very, sometimes, you know, your boss or your coworker. I actually know of some people which, you know, have to use the code which was written by their boss, who thinks it's perfect, and now it's a bit outdated, but they still have to use it. And well, this list can go on forever, but
I always blame the hypothetical intern that we haven't hired yet.
okay.
You know, that's what's going to happen. Some intern's going to come along and write this really bad.
So one thing I've seen is there is in a lot of places too much in time spent in programming and, you know, doing things, as some people think, not enough and thinking about what you're actually doing. So actually, I don't know the source of that. I haven't found it on the internet either. But yeah, weeks of coding can save you hours of planning, which I think too much people do. So, which brings me to my first chapter of this talk, which all in the original way motivated me to talk about the whole topic. But once I got into thinking about it, I realized it's just not this. It's just broader and bigger topic. So the Pullman C++ I probably should first design, who that poor man is, or person. A person whose main concern is not C++. C++ is seen in the role as of a tool. And for example, this is just one category. Also, after thinking about it more and seeing examples, the poor man usually is not poor. They're just not a C++ expert, and often they have basic or poor C++ knowledge. They're often an expert themselves, but in a different domain. So one example is scientists, and other example could be people coming from other programming languages, bringing habits with them, which they then continue using in C++. And that's probably not the best way to do it in C++, because in C++ has few patterns which are different from other languages, as we have no garbage collection. And it's probably not even their fault that they write this code. As for them, C++ is only a tool, and as long as it works, it's okay. And they often also have limited time to improve the skills, as long as it works. And I've seen also as freelancer, people do copy-paste a lot, actually too much. And it's kind of in those places where you see this copy-paste evolution, when part of the code base is already copied over again. And often also, some modern systems like we use, like checking in code, it's not done in all places, and so old code can live very long in this case. And typical problems with this, it's poor design knowledge, so that some things get over-engineered and could be solved easier. Mixing old techniques with C and to C++. C with classes was originally the name of C++ very, very long time ago. Unfortunately, a lot of people still think they should mix C++ and C. And another big problem, in my opinion, are old C++ books. Because once you have in a company a C++ book or several C++ books, the motivation to get new ones or to stay on top of how people should do with modern C++, it's not in all places really done that way. So also, problems with new memory leaks are very common, and of course also, especially if you have older code and newer people working on it, you have a certain clash of styles. Which we currently can see also in our community is like this typical thing of loops versus algorithms, where some people think that loops are bad and you should use algorithms, and other people they just love their loops. They're lazy and they will probably continue using them. So, but in my opinion, there's hope. As they're experts, they're usually willing to learn, and so they can be educated, they can be reached. But they may be hard to reach due to workload, and C++ is not the primary concern for them, though they might not be really interested in improving their skills in a way they probably should. And sometimes also the attitude is a bit of a problem, I find, because things work and why should they change it? Which brings me to a short chapter of examples of bad code, where we are going to see some examples. First, I think I should talk about memory leaks, as it's, in my opinion, the biggest problem with some programmers. Layers of engineering, which is not so much a technical problem of C++, but a bit of like cultural and of course class design, monster classes, methods, functions, init patterns. I will talk also about money, and of course I have to mention switch, and I also will have a short talk about a certain library, which is not in Boost. So, memory leaks. There's a certain overuse of new. So, especially when people come from other languages which have this new idiom that you just create your variables with new. This is a big problem, especially in the space where apps are written. I've seen this a lot with Qt happening, that people coming from Java just allocating the objects continuously with new, and also the deletes are often either forgotten or new has usually not an one-to-one connection to a delete, and so sometimes a problem can exist that people think that if they have one new and one delete, they're done, and they probably don't realize that they should also have other deletes. And if you introduce ownership concepts like smart pointers or object hierarchies like Qt does it, this can reduce the problem, but this can also lead to other problems. Where I would like to show a small example. This is code from Qt, just as an example, but actually it's common to have this like copy-pasted all over some programs. We have some action where some button, some menu is triggered, and we create a dialog with new, because that's probably how you should create a dialog in Qt. It's okay. And after this function is left, we have a memory leak. Now Qt has this object hierarchy, so we could just insert this pointer, and ta-da, we have no memory leak. The problem is that each time we call this function, this dialog of course is created again, which some people don't realize. So actually we have created a resource leak out of our memory leak. One possible solution to fix this is to put the dialog on the stack, which also works, but has one little problem. Pass this in, and this internally makes this a child and takes the pointer to this my dialog, which is on the stack. If ever this parent gets destroyed before the parent gets destroyed before the before its child, we have a little problem, because if the parent delete happens and we have here something on the stack, it's I think undefined behavior, or calling delete on a pointer which is not allocated with new, probably not a good idea. A solution to this is to call, which is in this thing Qt specific, to call delete later. And just calling delete on the dialog itself would not be such a good idea, as behind this in Qt runs an event system, and we probably want to make sure that the event system still can process messages before it really kills the instance. And if you really want to be sure, you should do this call to delete later in a scope exit block, like for example Boost scope exit. Qt itself does not provide such a functionality as far as I know. And yeah, memory leaks again. What I found is that resource accuracy, the RI, is still in similar techniques which I used. They're still rather unknown in some places. And also smart pointers. Actually, I had one designer of a mobile API asking what smart pointers are. That's why I put the question up there. So even people doing design in the industry for SDKs sometimes don't seem to know what this really is, what a smart pointer is. But in my opinion, if you start with overusing pointers, overusing smart pointers is not going to really get you anywhere. It solves the memory leak problem, but then maybe you get addicted to shared pointers, and in my opinion, the code quality really doesn't improve through that. So probably quite unsurprising for you, you should prefer the stack to put your variables, and then if you have to use new, use a smart pointer, and raw owning pointers, no, don't use them. Short few words on refactoring. Introducing smart pointers, it can be sometimes hard, as interdependencies can be quite widespread in an older code base. And as I said, pointer overusage was a smart pointer overusage. Also, I had a rare case as I was a freelancer. A delete actually executes code. So we had an import program which imported a large XML file and had a lot of memory leaks. And fixing those memory leaks, of course, made the program slower. So at the end, the management made us take away those deletes again, because they were basically saying, yes, it's an import program and we want the speed. Which brings me to the next topic of layers of engineering. There is a certain, sometimes you can find places where code is very, very structured in layers. So you usually have like a nice surface and rotten hidden parts which are older, which nobody really wants to touch or can't touch. Example for that is classically projects with a longer history. Projects that have a lot of dead code are also a good example, or projects that are not getting touched for some years because the product just works, and then comes a new feature and they want to have the new feature added. And then you can find code like with comments like this, where, for example, communication with some hardware devices is, and it's basically just raw code or assembler, and people just don't want you to touch that code because it works, but nobody understands it anymore because the project was like basically sleeping for a few years and the actual implementers are gone. And what sometimes happens then, that people just instead of doing a refactoring, just add a layer on top of it, though they can deal with the code, but the code is effectively staying in place and still active, but it's trying to wrap it nicely. And also usually documentation. Who writes documentation? Yeah, that's actually true. So typical in such an environment, I think, is the workflow of having new features are more important than bug fixes. Bug fixes are then, of course, more important than refactoring, and refactoring is more important than documentation. I did do this talk once before in my user group, and one friend stated then that in their company they're not allowed to do refactorings, because as we all know, refactorings are dangerous and bad. You shouldn't do that. So he says whenever we have a bug in a place we want to refactor, this bug fix will get a little bit bigger than it should be, and we try to hide our refactorings through bug fixes, which of course makes it difficult to refactor parts which are probably a bit more mature and don't have so many bugs. Then maybe they introduce bugs to refactor, I don't know. And this, I think in some places this leads into this vicious cycles out of new features, new bugs, new features, new bugs. Not very pretty. Which brings me to class design. Unfortunately, monster classes are still very, very common in the industry, especially if you have like legacy products where the code is older and not like yet newly written. Yes?
Can you explain what a monster class is?
Oh, of course. A monster class is something like a God object. It's a class which has basically too much functionality. So you have a class which has like hundreds of methods and 20, 30, 60 or 100 members. It has like a dozen things to do, or it's basically the place where people start implementing and then continue to implement, and it's never getting refactored, and every new feature gets its new method in this class. So after a while you have, which is also very common, that code files get quite large, and which brings me, now one of the next slides is then about monster functions and monster methods. And in the same way, people then introduce a lot of pointers or introduce dependencies, which are then often lead to a very long compile time. And some people also, there's a certain style in some places where C++ is tried to be used just like Java and being strictly used in object orientation. The style does not play very well with Boost, in my opinion. In some places it kind of coexists, but if you, I had one place where I originally introduced Boost, and they're actually using it quite well, but they had a problem with how I used Boost, and they were practically having all their classes and their object-oriented style and their handlers and everything, but using like Boost function or something was like for them unheard of, and they couldn't really deal with that, and I had to explain that code to them. And one problem I found this year is also interface versus implementation. A very nice bug I found. So there's a parameter class which has validate. Already having this validate function is questionable, in my opinion, because you can have an object which can turn bad, or can contain a wrong value, and then you can validate it. And we have two validate functions. So this is real code, which both return true in their default implementation. And here the first parameter in the first function is a field ID, which is basically some kind of enum integer, like a field ID, and the other one has the same thing as a name, as a string. And the implementation is, of course, first they copy-pasted the class, and it's of course then in the CPP file. The implementation is just now for the example is slight C++, as we learned yesterday. They have a long validation, but if you use the other function, it still returns true. And one of the few ways to actually really fix that is to go in the header class and see if we can call the other validate function, which then was a fix. And of course, you also have to fix your code and delete the other not anymore needed validate method in the children classes. One problem with that style is that this also came from using copy-paste, and I hope we found all places where it's used and we could fix it everywhere. And basically in their code base, mainly this is used, and there's currently just 2 developers using this code, and they're trying to introduce more developers which use this API, which also of course is not documented. So one developer which is not familiar with their code base could very easily start using the second method, and then suddenly you would have an object which always returns true, even if actually a validation should happen if it's still valid. Such a validation could also be, for example, a check if the value has changed in the database or something behind it. So and talking about class design, there's actually a pattern called non-virtual interfaces. With, in my opinion, if you use object orientation, it's actually a good pattern which you should use, but I have seen it actually never in application code. I've seen it very rarely, and also have met very few people actually who know what it is and why and what it's about. So in this case, you have a private virtual function or protected virtual function, and the actual interfaces which are called through the base class or through the child class are public but not virtual, so that you always can have in the base class the possibility to check the basically do some logging or not expose the virtual interface to the user through this. And this, as I said, it's very rare to see it. At least I have rarely seen it. And of course, when I speak about class design, patterns, gang of 4, it's a good knowledge, in my opinion, to have. And but the problems with patterns is they need to be used correctly, implemented and used, and also, in my opinion, correctly documented. Because if you use a pattern and it's maybe not in the class name directly visible, it's probably not the best thing to have a pattern in the code, just trusting that the developer which comes after you will be able to see it, or maybe if you still remember your own code after 2 years or 1 year. So I think patterns always should be documented. Which brings me to a slide about monsters. I already mentioned monster classes. They are quite common. Layering can be a cause, in my opinion, when people just, are caught up in their daily business and they just keep adding new features because management wants them to. And another thing which is quite common are monster methods and functions. Actually, I'd love to have a tool for just scanning a code base and getting the average and median method lengths in line of code. And maybe also, add some sort of filter to be able to kick out the smaller functions. Because what I've seen, especially as a freelancer in the industry, is code which has several thousand lines per functions, and normally functions start at 100 lines. And that's not very readable, and it's very hard to refactor properly once you have so many code in this matter written. And of course,
It's a good time to replace the battery.
we could replace, yeah.
It's not yellow.
Thank you, Dave.
Thank
Yeah,
you.
thank you.
The tool you want is called Source Monitor.
Okay.
Measures code complexity on a variety of languages. I've used it a bunch of times on C++.
Okay, so the common,
Free for non-commercial use.
okay. So the comment is such a tool seems to exist. It's called Code Monitor.
Source Monitor.
Source Monitor, and yeah, it's free for non-commercial use. And have you used it?
Yeah, I've used it a bunch.
Okay,
It
so
reports a variety of complexity metrics, of which length of methods and functions is one.
okay, good to know. the init pattern, I actually can bring an example. Or not an example, I didn't want to put code for this up. This is actually a pattern which is quite common, unfortunately. So there is a class which has an init method, and the class is only valid in construction if the init method gets called. But the init method, of course, gets not called in the constructor, where you could still argue about it. So a valid object must call init after construction. And an example for this is the famous Beta SDK from Samsung. And I've seen it also in some projects in the wild. One of the causes for doing this can be that people want to call virtual functions. And as you probably know, that does not work in C++ because you cannot call a virtual function of an object that's still under construction. Unfortunately, you can do that in Java and .NET and maybe a few other languages. So people coming from those languages, some of them have this pattern that they call virtual functions during construction. And so they try to make this work on C++ also. And well, and how to fix this? Use constructors properly. Avoid virtual functions calls, especially for initialization, because it doesn't work in our language, and I guess it will not change. Yes?
We found that delegating constructors helps to avoid this pattern. That the new feature in C++ 11 where you can call another constructor, we frequently end up falling into this pattern because we have some longer method we need to call. Yeah.
So the comment is this pattern can be replaced very good in C++ 11 with delegating constructors, and yeah, that's a good point. Well, and sometimes you just can't remove this from your code because maybe it's you're writing software for BADA, or I think this is also valid for Tizen, a newer software for mobile phones from Samsung and Intel. And in this case, you still can handle it, in my opinion. You should, in your objects which you implement, force make functions or factories, make your constructors private. Maybe don't forget certain operators which also could construct objects. Rule of 0, rule of 5 defaults, and if you have no implementation, and that way you can create the object in the factory, call the init function, and then return the object. And this way you can enforce that the object is properly constructed, and hence safe to use for your users. So money. There's a bunch of people actually using float.
I have a comment.
Yes.
When you're talking about classes, you touched on this, but one of the things that's good to follow is composition versus inheritance. Several of the anti-patterns that you mentioned in here are attributes of always going with inheritance versus using composition instead.
Yeah.
So I just thought
that's true. Yeah. So the comment is that instead of using inheritance, composition often can solve a lot of problems, which I agree with. So if you inherit from a class, it should always be an is-a relation and not a has-a relation. But in this case, inheritance doesn't apply because people start using for money float, for example, or double. I actually have one client which has this problem, and they're not able to fix it because it's basically all over their code base, and it would be too much of an effort to fix the software because the software is basically live, and they don't want to fix it. So the problem, with floats is that they're not very accurate, and every now and then this makes you lose a cent. So in my opinion, if you deal with money in your application, you should make it a type and store it as, so for example, you can store it as cents in 1000 units, so you can use some kind of integer also to store your money in cents or thousands of cents. And I think money is a perfect example for a value type. And yeah, this came up on the picnic. So money as floats doesn't make sense. It makes you lose sense. Which brings me to switches. Found this somewhere on the internet, and so yeah, this is probably auto-generated code, but switches are sometimes useful, but in my opinion, often you can replace them either again with inheritance. You can use a map with functors, and you can of course use polymorphism inheritance I already mentioned. And you either can do that at runtime, or you can use static polymorphism to replace a switch. So there are patterns which are better than using a switch for a lot of things.
I call that a doctor error. After an old job. Doctor, it hurts when I do this. Well, don't do that.
Yeah.
It's interesting, in our count project we have the opposite rule. Whatever you can make a switch statement, because with the corresponding warning and error handling of the compiler, you see whether you miss one option. So only use switch statements without default. So if you have a limited range of possible values, you see that you miss one possible value in your considerations and in your code.
Okay, so one comment is that you could use switches in the way that the compiler will warn you if you miss a value, and that this is actually then a good thing to do.
Yeah, then that becomes increasingly more important the more frequent in your code base you have that particular switch statement, because then every time you add a new value to the enum, if it's 3 places that you got to update, every now and then you forget one of those places, and boom.
Yeah, exactly what that is.
Which brings me to a personal problem I had with a certain library, which I hope you never meet, but they actually have updated their dependencies, but for us there was a huge problem. There is basically no other option than to using this library in C++, because they implemented this protocol, and if you don't want to implement it yourself, then as a freelancer you mostly are just paid to do a solution and not to implement things. So they wanted me to use this, and of course it's fully documented. It uses and brings boost 1.33, which you might not want to have in your code base, because you should use a newer version of boost, as we did. And another problem which we had is it was not intended to be used alone. The core users had this library just implemented because they needed the protocol, and this is actually a framework for doing voice over IP. But we were not doing anything in that direction. We just needed the protocol to actually implement a remote framework for basically administration from over the internet, so that you can access your machines from a remote place like this hotel. So solution, of course, updating the library to a newer version of Boost. Unfortunately, my client did not want to do that because it's losing time, which doesn't help them. The library itself has now, I think, updated to Boost 1.5.0. As I saw for a few weeks as I checked their code again. And I basically created a public interface which does not expose the library and created a private implementation and one CPP file which uses the library. And so we had one CPP file which compiled in a DLL, and then we had no leaking into the project through this. So even if you often cannot change bad code, you still can, kind of contain it and deal with it later or update the library later. Or, for example, anti-patterns was already mentioned. I like the positive patterns much more, so I made this a little bit bigger. So there's also a book on anti-patterns, and while design patterns are very well defined, anti-patterns are a bit like so cloudy. Just did list a few ones. Singleton is commonly depicted as an anti-pattern, especially as we are now living in a multi-threaded era where singletons are not that easy anymore. Got objects, just objects with too many functions, which just basically know too much about the application and should be split up into smaller objects. Monster classes, etc. Object orientation only pattern and style is, in my opinion, an anti-pattern. At least in C++. In Java it's not. In C++ 11 and 14 we probably will see that new and delete become an anti-pattern, because then we can use make unique and make shared and have everything, if we need to use new, wrapped in objects which take care of the memory if it leaks. And there is an online anti-pattern catalog which describes a bunch of patterns, and this anti-patterns go also in a way in cultural things, and so while design patterns are strictly technical. So thanks to Tony. I had to bring this slide in here, and you might remember somebody else also made this climb. I don't have it in a better resolution, unfortunately, but this was a keynote from David van der Vaart about modules in 2012. I think maybe some of you remember. So more examples are probably at a code base near you, in my opinion, and I think we all have seen some of those patterns already in the wild, and of course, if it's not in your own code base, it might be in your next job. So when talking about anti-patterns, it's not enough, in my opinion, and bad code just to talk about how to fix it and show some examples. It's also kind of important to see why it exists, and so in my next chapter I'd like to talk a little bit about generally how to deal with bad code without really to generalize on examples, and then I will go a little bit more deep into where I think actually, in my opinion, if I go into the problem of bad code fixing, of course, whenever you can fix it, you should fix it, and you should not become Don Quixote, because maybe it's just a symptom. And also, as I've showed you, there's some possibilities that you cannot fix a certain part of the code, though you also still need to deal with that. So fixing involves refactoring, which, as we all know, is fun. Actually, another very good slide I've seen about refactoring this year is this statement, which was made by Martin Fowler this year at a conference called OOP in Munich. I think they don't do anything with C++, but This is not available as a video online, but if you search for Martin Fowler, there is a short video from his keynote online, which is actually very good, but not has anything to do with this. So basically, he claims here, when you want to refactor, you should argue with economics, and I agree with that. Arguing with quality, clean code, professional, and of course the right thing, will probably not be understood by your management. So, as I said, I want now mainly to talk about dealing with bad code. So, of course, nobody has bad code that's not used, because then it would be dead code. Fixing bad code involves dealing with it. Refactoring or rewriting is not always an option. And of course, new or unknown parts of the code base are a possible threat of new bad code which you haven't seen before. So, in my opinion, as a freelancer, especially important is always to see what kind of code base you have at your client. So there actually exist tools which give you a bunch of information about code. For example, CPP check, Planck static analyzer, a bunch of commercial tools which also do code analysis. This gives you usually a first overview. You also get a list of things to fix, which you can show to your own client, or which when you work at that place and when you're employed, you basically can make this your first work item to fix the errors in your new code base. And also there's a tool called Clang Modernize, which, as we learned today, seems to crash on some code bases, but it's usually actually also a good idea to run this on a code base if you want to move to C++ 11. As far as I know, it will very, very nicely update your code into a better style, not necessarily, but it will fix a lot of memory leak issues, make the code use smart pointers, etc. So that's definitely one thing you should take a look at. Clang Modernize is very impressive. Yes.
You mentioned the Heartbleed, and recently there was a pretty good article, a blog post about the guy who was able to use static tools to walk through and figure out the Heartbleed issues using static tools. So might be interested in that on the OpenSSL baseline.
Certainly, everybody who has a static analysis tool suddenly started scrambling to see how they could detect that kind of bug.
Mm-hmm.
Yeah. Which, yeah, that's again, those tools can help you, but they're not perfect. There were a bunch of commercial vendors scanning with their tool OpenSSL, and they did not find Heartbleed. So they're not perfect, and CPP check and Planck static analyzer are neither perfect. The commercial tools can have a bit of a better ratio of finding bugs, as they're built by a team which concentrates on this. And of course also with Doxygen, with documentation, Doxygen and Graphviz is a very good combination which can help you a lot in getting known into a unknown code base. And in this combination, Doxygen can generate call graphs, it can generate class diagrams and a bunch of other diagrams which basically help you understand the code base which you are currently working on. Because usually documentation is rare, and I've seen at my clients that they're also usually very happy to finally have a documentation. Of course, what should you do if you cannot fix it? In my opinion, if you cannot fix it, you should still be able to deal with it as a C++ programmer. You should first, of course, don't spread it yourself. Don't try to adopt the style, and unless you're working on a company where basically bad code is also driven through style guide. And of course, when you have it contained, try to fix it later. And well, in my opinion, fixing is a good thing to do, but you have to get somehow to the source. You have to prevent bad code, because then you don't have to fix it in the future anymore. So you should educate your teams and co-workers, and in my opinion, very important to also educate the management, as in my opinion, bad code is in a lot of places also caused by the management, that people don't have enough time to implement. And as a freelancer, I know that you have 3 days to implement a feature, then you do what you can do in 3 days. And usually, when I was a freelancer, people don't really give me feedback on the code quality I did, which is actually kind of bad over time. But so also, you should analyze how to improve your team's code quality. Very important, I think, especially now with C++11, you should update your company's C++ books, and don't reinvent the wheel, and use libraries where you can. Yes?
I'm going to use a 2-letter word that usually makes software engineers break out in a rash. Unit tests. Even the most minimal unit testing would have prevented go to fail and heartbleed. And I personally don't trust the library that doesn't come with a suite of unit tests.
I'm getting to that.
Oh, okay, sorry.
I think you're right.
So just one thing that I've done to help educate teams is put the IDE and the code up on a projector and refactor it as a group. Find the most ugliest code you have and refactor it as a group. That is a great way to disseminate the knowledge to everyone on the team and involve them in the discussion, instead of feeling like it's forced on them.
Yeah, that's what I think too. That when you want to educate your team, doing things interactively and like you said, in front of people is a very good thing. But I'm currently at libraries, so I think it's a good practice to develop in modules and libraries. Well, we don't have yet modules, but this week the first concept for modules was sent out. So there's a little bit of movement in that direction in C++, in the standardization at least. It still will take many years till we can use that, I guess. I think that even in application code you should prefer libraries. So as this forces a thought on the interface and how you want to use it, and it makes it easier to pull some part of that code into a different code base and reuse code. And it forces everyone to think about what they're actually doing and which dependencies they want to have in that library and how they want to compile it. So instead of having your application as a big monolithic block, you probably want to do that. So you have an application layer of libraries, you have like the other libraries which boost, etc. And then you could have unit tests. And of course, your application stub, which basically links together your application and has a little bit of code still, of course, in there. Yes?
What you described there are not unit tests. Unit tests are part of a layer, like a library. So black box tests are more application tests or something like that, which is good to have, so to be sure that the layer is there. But
yes.
the unit tests are usually part of your library, or should be.
Yes, of course. What I mean is that you can cover your application, which uses libraries, with unit. Maybe I should make this boundary here go away. But you're right. The unit tests should be part of the library, which are of course there. But I put the unit tests extra there because I think they should be used, which they're mostly not. So In my opinion, you should prefer library code over application code. And also, one thing you should have in mind that all code decays over time as the language advances and we get new insights.
Just a comment about code decays. Why you say it's true? If you leave a code around and don't touch it for 2 years, it's not going to decay by itself. See what I mean? Because there is often a tendency to believe because you have old code, it's going to be crappy code. But my experience is that the most crappy code in your code base is the code that gets changed the most often.
Can I just answer that? Well, I can give you a concrete example how code decays. And you depend on something, for example, boost file system, and then they change the API and deprecate it, and eventually, remove it, and your code doesn't compile.
Okay, in that case.
Yes.
Is that something you can fix by actually preventing change of dependencies to link to whatever is on top of it? Usually the main problem we have is file system changing its API or its format of its object is because we are transferring file system object across our API, which is actually the most bad idea we ever had.
Okay.
In my case, I didn't really expose the file system, I just used it in my code stuff glue.
Well, that happens. That's not good. I mean,
But it's
yeah,
an
yeah,
example of a code decay.
Okay. Yeah, it's code in here.
I just wanted to say that yeah, it's not so much that code decays; it's that the environment that it lives in changes. There are extreme examples where this doesn't happen, like say ATM machines, where 90% of the ATM machines in the U.S. are running Windows XP and probably haven't changed in 15 years. But in general, you get a new operating system, you get a new version of your standard library, you get a new version of your compiler, you get a new version of libraries you depend on, and in general, your code requires work to keep up with changes in the environment, and that's when I think of code that decays.
Yeah.
The second part of that is, hopefully you get better at writing code, and you look at your code from a couple years ago, and you say, I can do better now.
Yeah, you should.
Yeah, you should.
I actually think that is part of the problem because, you as people grow as developers, I'm not going to write, I'm not the same developer I was 6 months ago, so I'm going to write different code. So it's like having multiple people working on the code. And the more people or the more mindsets that I've got working on a code, even if it's just
Yeah,
me
but
from 6 months ago.
what I want to express with this is that you actually, that code needs to be refactored after a certain amount of time. And of course, the time it needs to decay is differently. Good written code decays a lot slower than bad written code. Which brings me to something I call bad code culture. I literally seen it in a few places where you have a certain style of management, where you have product manager and a project manager, and a lot of those problems, I think, which actually lead to bad code in the industry are caused by hierarchies that basically the decisions on how to implement things or how to do things or how much time there is to do things are done by an upper layer of management, which either does not have the right knowledge or not anymore the right knowledge, as they have moved up and are now more in a management layer. And so there's a lot of places where the communication from the management level to the actually working level is kind of one directional. So at one of my clients, basically the project manager decides how much time a certain feature and implementation takes, and then their programmers can see if they get this done in this time or not. And they're working in kind of a challenging field also, so the one feature which I was working on was not in the time slice they wanted. And yeah, as I said, bad code culture. Bad code is not always, the people's fault. Nobody actually, writes bad code as their day job and likes that. So there's bad work environments, and testing is not an industry standard. It's, in my opinion, often not understood what you should do with testing, and test coverage, which I've seen as a freelancer in the industry, is rather poor or zero. And also, not all IDEs and tools produce good code. For example, some class generators produce like empty destructors, and that's not really leading to a better code quality. So, which brings me back to this layer of engineerings. This cycle and tests. I basically, as a freelancer, was never really asked to write tests. It was in a lot of places, I have been for 2 years in a test environment at Vodafone. So I usually asked how they test before I, started working for them. And it's not really that people have their sets of unit tests, which they should have, of course. So there is actually, in my opinion, a lack of testing. We should test more, but it's not done because people don't understand testing and why it's important. And but people think that they test, and of course they don't do unit tests because they didn't get it running. The tools are not there. Testing is not an industry standard, in my opinion. If it would be, I would have not seen it in this way. I've seen it as a freelancer, and yeah, I thought maybe I should mention a few test libraries in this slide. There's, of course, Boost Test. Google has a framework. CPP Unit is there for ages, and C++11 there came Catch, which basically also is available in a version which also runs with Visual Studio 6.0. And there's a bunch of more libraries for testing. So actually, some people seem to care about that. But if you go into IDEs, most default projects, they should include tests, but they don't. Test coverage in tutorials and books is often rather poor, if at all. And that leads that tests are heavily underused in the industry. So one thing I'd like to know, who of you writes unit tests at their job? Okay. It's a very good coverage.
I have a comment on that. I think that there might be a difference between companies that have a product they maintain and companies that write software for their own use. I don't think that any critical commercial project can survive without having test base and code quality, etc. You will be out of the market pretty soon. So
This is possible.
databases have it, Microsoft Windows has it, everywhere, and they have it. Otherwise, no chance.
Yes?
There is this third category of software between that. Software that the company writes for specific use of another. Classic case of business software, which is a huge thing.
Yes.
And that is very often very lacking in tests.
Yeah.
So I know of a company that develops big software like that, and yes, they have this test cycle before every release where they have a list of things they try out.
Mm.
Unit tests?
Right.
No, there are no automated tests at all.
Unit
Like
tests,
there are some unit tests, but they don't actually pass and nobody runs them.
Mm.
So there are no unit tests.
So, yeah.
but that, again, unit test is from the developer. You're talking about system tests.
I'm talking that the only tests that exist are system tests, and those two are not automated, and yet they stay in business. They stay in business because the company they wrote the software for is pretty much locked in.
Yeah.
But they do stay in business without having test coverage. And it is commercial software. It's not sold individually on the free market, but it is commercial.
Just one comment. But it's a little bit different. But When I was asked once, what is more important, system test or unit tests? And my answer was system test, because unit tests don't prove you anything. So they only help you to gain quality. So as we have a talk about code quality, that's a good thing. But your product might behave very bad, although all unit tests are green.
So that's true, but I would add that if you write your unit test before you write your implementation, the main benefit you get from it is giving you a design feedback on the design of your class. You get the testing too, but the primary benefit you get is the design feedback of consuming your class before you've implemented it.
Yeah. Well, one experience I made, I wrote an offer for a client, and it was one of my first offers, so I put an extra point testing. And then the client removed that point because it was basically, that's a good point to save money. And then I said, well, I will probably...
Something about your client.
Yeah. So
you selected him? You took the job?
No.
Oh, good.
It's, I decided not to, because it was very too risky. I think.
Just to give some idea of software that needs a lot of testing, our database will have maybe 6 or 10 times more test code than actual code. And unit tests are a very, very small amount of code within that. Because unit test interfaces of the API and that kind of stuff, they are very useful because they catch the early bugs that can, they catch the butterfly effect, which would be very, very hard to debug if you get an error system test. But I would agree with what has been said. Overall, you're selling a feature and a concept to a client or just users, and that's what you want to test. And that's, for example, we don't test coverage. We don't know how much coverage our test do because we think it's very, very hard. It's not a good metric for us in our case, but however, we try to have as many complex scenarios as possible, and that's what takes so much code and time to run and to write. But in the end, it was a very, very huge win. We called very, very, very nasty bugs. It would have been impossible to debug in production.
Yeah. And so the comment was that unit tests can not catch everything, that you still have to write also code for system tests, but that unit tests sometimes can prevent you from some sort of butterfly effect, that catch an error early and then not have it escape in your production code. So one point I still want to make is our own industry is not very healthy. It literally kills people every year. So life is too short for bad work environments. If you can't change it, get out, get a new C++ job. Which, in my opinion, if you're really in an environment where you're not happy, that's probably the best step to do. And yeah, regarding to this, So, but also when we see the bigger picture, we're moving towards a newer, better standards. I mean, hopefully better standards, as we've seen in the keynote. Not all code can be rewritten. The code base in the industry with C++ is huge, and with a constantly evolving standard, the refactoring and the code adoption should happen more often. And with education, of course, as you all know, you never finish learning, and with newer standards, you can, with basically 10 years of very little standardization, you might have a chance to have your style at a certain level, but now you need to adapt again. We have move semantics, etc. So fixing bad code does not prevent it, so we have to see how we can actually educate our co-workers and people who are not as interested in C++ that they go to conferences. So in my opinion, we need to see how we can educate and reaching more people who write C++. And one very good thing how you can reach your own co-workers is doing code dojos internally in your company. This has a very good training effect, and it's also not as forced as like a training, which is very frontal and that cannot reach everybody.
What is a code dojo?
Code dojo is there's the web page, but I haven't linked it yet. Basically, you have a group of people coming together, and they're solving a certain programming problem in pairs. So there is you have a group of 8 people, and then you build like groups of 2, and you then have always 2 of them in front of the group solving a small step of the problem, and then the next group comes, and that way people can learn. And you also could through this you could do the same thing with refactoring, as here the example that you can refactor your own bad code in front of your team or with your team in a discussion, so that they learn how they should maybe also improve their own code.
We're also experimenting with code dojos in user group meetings or C++ meetups, getting together, grabbing a small.
Yes. So the comment is that code dojos are also very good for meetups of user groups, which I agree with. We already have done that in Düsseldorf too. Which brings me shortly to books. C++11, I think what Bjarne thinks about is probably worth reading. And also there's a C++ primer, which is a very good book, and about API design. Of course, modern C++, there's not yet, I think, Scott Myers works on a version about modern C++, kind of probably the successor for this book. And there's a book called API Design for C++, which I actually brought. It's, I think, it's not going very deeply in all topics, but it has a very broad overview on a lot of things, which in my opinion is a very good book to read to people which want to improve their own style, and especially might want to learn a bit about how to implement libraries and have code more reusable. And on my own webpage, I have a list of recommendations, and there is a list of Stack Overflow, which I've linked in my slides. As I mentioned, this is a book which I think is a very good resource about C++. It's called API Design for C++ from Martin Reddit. It gives a good general overview over different development-related practices, for example, testing, scripting, and API design. And the community. I think it was also in 2012 I've written a little blog entry called Islands of C++. So our community is very versatile. There are many small islands in a big ocean, which basically the water is like the standard. And C++11 brings a lot more libraries, and we should and we need a better exchange and flow of knowledge in the community, because in my opinion this lack of exchange of knowledge also is one of the sources of bad code. So C++ user groups are for me a building block in this, as it's a local active C++ network, which would help us reach much more people, and also educate them, maybe get them in better jobs, exchange of knowledge, and maybe find a few talents which we otherwise probably would not have found and maybe lost to other languages. And for me, it's a basic building block for the C++ community in a global and interconnected way, where that's kind of my vision. Another thing which I see is that there is currently a trend of this Internet of Things thing called, it's not just a buzzword, with a combination of hardware and software getting cheaper and sensor getting cheaper. There's currently a trend to, you know, having a lot of new things out there. So, in my opinion, we should also try to that this Internet of Things is based on C++14, maybe LLVM, Clang, GCC, etc. So we should be able to help and create a better future with C++ with the newer standards.
Is the Internet of Things a better future? Couldn't resist.
It's a future. If it's a better, I don't know. Which brings me to my conclusions. My goal for this talk is to make you think of a solution that fits your needs, as I think there's like no global solution to this problem. Bad code means a lot of things, depends also very much on your own knowledge. In my opinion, you should prefer library over application code. And when you're dealing with bad code, fix or at least improve it if you can. If you can, then don't spread it. And if you need to deal with it and cannot fix it, then contain it safely. As I said, let tools help you. There's static code analysis, there's Doxygen and other documentation systems, as Boost, for example, does not use Doxygen. And there's Clang Modernize, which can help you to improve your code base already a lot. And yeah, as I said, prevention, educate your teams and co-workers, and of course don't forget your management, as they probably make decisions which lead to the way you have to work. Update your C++ books, and couldn't resist visit C++ conferences, and yeah, be engaged in the community, share your knowledge, teach others, and we might be able to, you know, have less bad code in the future. And one thing that Eric Niebler mentioned in his keynote last year, which you should do, is try to commit at least once a year to an open source project. And in my opinion, C++ 11 and C++ 14 are fundamental standards. So we should see that we are able to create a better, a better world with this modern C++. That we really try that the code base is changed to this style. And in my opinion, modern C++ can already prevent a lot of bad code. And yeah, thank you for listening. And any further questions?